Okay guys, today we are doing 11.3, solving equations with variables on both sides. We did something similar to this earlier in the year, but we're going to kind of review and add a little bit more challenging stuff with it. So first we're going to start with a warm-up, 4 questions, stuff that we did last week. So this should be easy. Go ahead and do those now and type in your answers. Okay, now that you've done them, the first one should have looked something like this, combining like terms, combining 2x, positive 9x, and negative 3x to be 8x plus 8 equals 16. So solve like normal, subtract 8 from both sides, 8x equals 8, divide x, you should have gotten 1. For number 2 here, it's the same thing, combining like terms. You have a 6x and a negative 4x. So we're not using the negative 4. 6x minus 4x is just 2x plus 22. And again, solve like normal, starting with addition or subtraction. Minus that 22. I'm left with a negative 26 equals 2x. Divide by 2, divide by 2. I've got negative 13 equals x. So for number 2, you should have got negative 13. Okay, for number 3, this was clearing fractions from last week where you find the least common denominator. Looking at these fractions, all of the denominators have a 7, so I'm going to multiply everything by 7 to clear those fractions. So I'm going to take 7 times 2 7s plus 7 times x over 7. And I'm turning this improper, so 7 times 5 is 35, plus 1 is 7, then that's 36 over 7. So this makes our life easy. We can simplify before we multiply. These cancel out to be 1, so I'm just left with a 2 plus these cancel out to be 1. X equaling, cancel out to be 1, 36. Isolate the variable, get rid of this positive 2, left with x equals 34. So that should have been your answer for number 3. Okay, as for the last one, this is probably the most difficult one. You had to look at all the denominators to clear the fractions. And looking at 16, 4, and 8, to clear it, we should use 16. Don't know why my computer keeps doing that. Okay, so we're going to be doing 16 times the 9x over 16 minus 16 times 2x over 4 equaling, and again I'm turning this into improper, so 3 times 8 is 24 plus 1 is 25, so 25 over 8. Okay, so simplify before I multiply. These become 1, so that's just 9x minus, simplifying this, I can divide them both by 4, so that becomes 1, and this becomes 4. 4 times 2 is 8x equaling, okay, 16 and 8. Can divide them both by 8, left with 1, and that's 2. So 2 times 25 is 50. Combine like terms. 9x minus x, that's just 1x equals 50. So this should have been your answer for number 4. Okay, today's learning objective, you are going to learn to solve equations with variables on both sides of the equal sign. Go ahead and write this down in the learning objective. Okay, so this isn't in your notes, this is just me kind of talking. Some problems produce equations that have variables on both sides of the equal sign. So we're going to look at an example that looks like this later. Noticing we have 4x plus 6 on this side of the equal sign, and then an x on this side. So solving an equation with variables on both sides is similar to everything we've been doing. We can add or subtract a term containing a variable on both sides of the equation, as long as what we do to one side, we do to the other. So here's some notes that we're going to write down in our handouts. If there are variable terms on both sides of the equation, first collect them all to one side. So we need to make sure first getting all the variables together on one side. We're going to do this by adding or subtracting. Next thing I kind of want you to jot down is, if possible, collect the variable terms on the side where the coefficient will be positive. Make your life easy. It's not always going to be that way, but try and make it that way. Okay, so for our first example, I kind of started out simple. We have 4x plus 6 equaling x. So we need to get the x's all to one side. So since there's just an x over here, let's get rid of this 4x. So what is the opposite of a positive 4x? We're going to subtract 4x from both sides. So we're going to do minus 4x and minus 4x. So this over here goes away. That becomes 0. We're left with 6 equaling. Now we have x minus 4x. Well, that's 1x minus 4. So that would be negative 3x. Then you just solve like normal. Opposite of multiplying by negative 3, divide by negative 3. Divide by negative 3. You're left with negative 2 equals x. Go ahead and try this one. It's very similar to our last example. Okay, so you should have gotten the x's to one side. Again, on this one, we're going to have to subtract 5x, subtract 5x. This goes away. We're left with 8 equals negative 4x. Dividing by negative 4, dividing by negative 4, negative 2 equals x. I did not have the same answer on purpose. Okay, so this one I added an extra step. Again, we have a variable on this side, 9b, and a variable on this side, 5b. So we could really go either direction here. We could do minus 9b from this side, and then minus 9b from this side. But that would create this here to be negative. So that's why we kind of try to make our life easy. And we're just going to subtract, knowing that we can do 5b or 9b minus 5. So let's get rid of this. 5b here and 5b here. So this goes away. That's just 0. 9 minus 5, that's 4b minus 6 equals 18. Well, this is a two-step equation that we've been solving since the beginning of the year. Start with addition and subtraction and isolate the variable. This goes away. 4b equals 24. Divide by 4, divide by 4. b equals 6. Okay. Go ahead and try example 4 on your own. It's very similar to the last one. All right, so looking at this, we could get rid of 3b, or we could get rid of 2b. Trying to make my life easier, I just want to subtract the 2b so I don't have any negative numbers. So minus 2b minus 2b. This goes away. I'm just left with 1b minus 2 equals 12. Solve like normal. B equals 14. If we wanted to, we could even check the problem. And we could plug in our answer 14 for B. So 3 times 14 minus 2 equals 2 times 14 plus 12. Well, 3 times 14, 3 times 4 is 12, 3, 42. So 42 minus 2, that's 40. And then on this side, 2 times 14 is 28 plus 12, that's 40. Both sides are equivalent. Our answer is right. Oops. Okay, so this example, it's going to challenge you a little bit. We have 9 W's on both sides, but we need to get the variables all to one side. So I'm going to kind of follow the pattern we've been doing, and I'm going to subtract this 9W here and subtract this 9W. But here's the deal. 9 minus 9, that becomes 0. But if I do 9 minus 9 here, that also becomes 0. So this goes away. So all I'm left with is 3 here equals 7. Does 3 equal 7? No. So in this case, this equation has no solution. There's no solution that works here. And kind of emphasizing there's no number that can be substituted for the variable w to make this equation true. We could not put any number in there to make both of those expressions equivalent. Practice this one on your own. Okay, so it kind of was similar to our last one. We've got a 3w here and a 3w here. Subtracting 3w from both sides. This one goes away, this one goes away. You're left with 1 equals 8. Can that be true? $1 is not the same as $8. Again, this has no solution. There is no number that can be substituted for the variable w to make this equation true. Okay, so a helpful hint is if the variables in an equation are eliminated and the resulting statement is false, the equation has no solution. So that's a possibility. If you're getting 0 and you're thinking you're doing something wrong, it could be that there's no solution to the equation. Okay, so at this point, you should go ahead and move on to video 2.